Good afternoon and welcome to today's HydroCAD webinar. My name is Peter Smart. I'm the developer of HydroCAD and I'll be presenting this afternoon's session. Today we're going to be talking about importing data from AutoCAD into a HydroCAD model. This is a very exciting and powerful capability that was added in HydroCAD 10, and this expands the range of options that are available to you for bringing data into a HydroCAD model. Before we get into the HydroCAD or AutoCAD details rather, let's just have a brief look or overview of the other import capabilities that are available to you in HydroCAD. There's quite a range of options here, and so before you really push ahead into a given project with one of those procedures, it's a good idea to have a general understanding of the tools that are available so that you pick the best option for your particular application. We have a page on our website that details the import options, and I want to go down these just briefly before we get into the AutoCAD details. In order here, the first import option we have is to import data from a HydroCAD 5 or earlier project file. HydroCAD 1 through HydroCAD 5 used a different file format than we're using in HydroCAD 6 or later. With 6 or later, all you have to do is open up that project, and it will open directly with any version of HydroCAD from that version forward. However, the HydroCAD 5 and earlier files are different format. If you do run into those, you can import anything right back to HydroCAD 1, but to do this you do need to go to Project, Import HydroCAD 5 on the main menu in HydroCAD. And that will bring in the data files and convert them to the current format. So it's fairly straightforward. You can bring in any of those files. Even 20-year-old files will still come in using that capability. The next import option worth noting is importing HydroGraph data from another HydroCAD project. So if you had a couple of HydroCAD projects or files or pieces of a project you've done in separate files, you can export the HydroGraph data from one of those files and then bring it into a second file using a link. And you might do this if you are exceeding the node capacity of your program, or if you simply have a very complex project and you choose to break it into several different pieces. And this page does have a link to the document that gives you details on how to set that up. Again, this is to give you the ability to automatically import HydroGraph data from one project into another. The next capability we have here is that we can also import HydroGraph data from another program. So if you have data that has been exported into a file, perhaps a text file or a spreadsheet format, a CSV format, then those are formats that can also be imported using a link. So that's something else to be aware of. Similar to that is the capability to import TR20 data. If you have a TR20 data file, then you can use Project, Import TR20, and that will pull that whole file into HydroCAD for you. This will also bring in any custom rainfall files that may be contained in that project. With HydroCAD 10, we also have the ability to import the rainfall data from a Win TR20 file. The other elements of the Win TR20 file are not imported at present, but it does let you bring in rainfalls, particularly any custom rainfalls that may be in the file. So that's quite powerful capability. You can also import data from other hydrology and hydraulics programs, particularly if they have the capability to export to a TR20 format. If they can export to TR20, then you can then grab that TR20 file and import it into HydroCAD. Next, we have capability of doing a tabular import. And this is very powerful if you already have watershed data which you've extracted perhaps from a GIS system or perhaps from a CAD drawing or other source. Then we can now pull in complete watershed data. That is all the data for the subcatchment, including the time of concentration and curve number and ground cover information. This is actually the capability that is the foundation for the AutoCAD import that we're going to be looking at today. What we're doing with AutoCAD is we're automating the process of manipulating drawing layers in AutoCAD, tabulating the intersections of all of those layers, and then bringing each of those intersections into HydroCAD as a sub-area. So one process really builds directly on the other. It's just that we've automated all the mechanics of that more fully in an AutoCAD environment. There are also a couple of other import options here on this page. For example, you can import a lot of the individual screens in HydroCAD in CSV format, so if you already had something like an outlet device rating table, then you could load that up into the screen by right-clicking the appropriate table. And finally, you have the ability to write conversion programs for AutoCAD, actually for HydroCAD, excuse me. The HydroCAD data files are set up as an easy-to-read plain text format. The intent is to make it as easy as possible to generate those files from other applications. So if you're doing any programming in Visual Basic or a scripting language or C or some other environment, then you may find it quite easy to export that data and write your own HydroCAD files. Of course, what we're going to focus on now today is bringing your sub-area data from AutoCAD directly into HydroCAD. But I wanted to give you a little bit of overview of some of the other import mechanisms that are available to you. So, to get started with the AutoCAD import capability, let's have a look at a sample project which is pre-installed with HydroCAD. This is the CAD import demo, and you'll find this pre-installed in your HydroCAD projects folder. And of course you can just click on the file to open it directly, as I did here, or you can launch HydroCAD and then you can do a project open in order to get to that file. However you get there, you're going to see a basic diagram like this with two nodes in it. The intent of these nodes is to show you that how you can combine data that's been entered manually through HydroCAD and data that's been imported automatically from your AutoCAD drawings. So in this instance, we have a subcatchment which has been named manual entry. And one of the things you'll notice about this that's a little unusual is this red arrow that's displayed. The red arrow indicates that automatic import has been enabled for this project. And the color or the intensity of that arrow will actually show you the degree of import that is enabled. If we edit this subcatchment, you may notice there's a new box down the bottom of this screen which is used to specify that you want to import the sub-areas automatically. This is not selected on this particular subcatchment because we've created this subcatchment by hand and we want to enter the data manually, so we can come in and we can make changes to this as we wish. Subcatchment data that's being automatically imported will be protected so that we don't accidentally make changes to it. So this is the ability that allows you to use both manual entry and automated entry within the same project. So this particular sample project is pre-configured to grab data from an associated AutoCAD drawing. To do the actual AutoCAD import process, we come over to the toolbar on the right-hand menu, or the right-hand toolbar, and you'll find a button here for watershed import controls. If you click that, there's a couple of options on the button. What we generally want is this first one for import now. If I click import now, this is going to go ahead and launch the drawing, the DWG file associated with this HydroCAD project. It'll open that in AutoCAD and it'll go through the import procedure. When it's doing the import, we have the status window, which is displayed in HydroCAD, and this shows you each of the steps that HydroCAD's going through. It takes a few seconds initially to open the drawing in order to get AutoCAD open, and then it goes through the process of doing the import. Now, it looks like for some reason here we have an error that's occurred. Okay, we've got an AutoCAD error that's occurred here. I have no idea why it's doing that. Let's just cancel this and try the process again. Okay, wonderful Civil 3D error. All right, let's try this once more. Let's actually just grab the drawing and make sure I can open that raw drawing file. Okay, the drawing seems to be opening fine. Okay, so with the drawing open, let me do the import from this stage. Okay, here we go. So this is the normal process that you will get as HydroCAD goes through, and there's about a dozen steps that it goes through to do the import. It begins by opening the actual drawing. If the drawing's already open, that's fine. It'll find it. If it's not, it should launch AutoCAD and open the drawing for you. It then goes through a number of result layers where the combined ground cover information is stored, and it erases those temporary layers. And then it takes each of the ground cover layers that you've defined. In this case, we've got woods, parking, and roofs, and it's overlaying those. It's combining them into a single layer, basically cutting puzzle pieces for each of those areas. Then it goes through and cuts the subcatchment boundaries on top of this and the soil group boundaries, again creating smaller and smaller puzzle pieces for each of those homogeneous pieces of ground. Once it's done all of that, it goes through that layer and generates a table of information and imports all of that data into HydroCAD, and then finally positions the nodes. And it also does some verification to make sure that if you add up each of the individual sub-areas, that area matches the total area of the subcatchment. So there's a number of steps that go on. And naturally, you'll get warning messages or error messages if it finds discrepancies in those layers. When it's done with this import, we can close this status window, and you'll notice we have a couple of messages that have occurred in the message window. And as usual, we can click on each of these messages for further details. The first of these is simply a hint that's telling us that it's used a certain amount of the default ground cover on this first message. If you look at the message, it's used 5,400 or 54,000 square feet of the default ground cover, and that default ground cover is grass in good condition. We also have a hint indicating that it's used a certain area of the default soil group C. The significance of these two messages is that we don't have to map ground cover or soil group for every single square foot of the project. We can specify a default that will be automatically applied to the areas that we don't explicitly map. If we explicitly mapped everything, then you wouldn't see these hints at all. You would be defining each square foot manually. And so you can click those messages, get more information on exactly what's going on. If there were discrepancies in the area during the import process, then we'd see red warning messages that would appear in that window as well. And we'll simulate a couple of those later on so you can see exactly how they appear and how you might deal with them. So what's happened in this import process is that you can see we now have two additional subcatchments that have appeared on this project that we have open. If we select any one of those subcatchments, we have a hot track feature which will simultaneously highlight the corresponding areas in our AutoCAD drawing. So if I click subcatchment 10S, you'll notice that these sub-areas over here are simultaneously highlighted. If we click 11S, then it will select those areas. So it will track and show you dynamically the areas in the drawing that correspond to each subcatchment within HydroCAD. If we open up one of these subcatchments, let's double-click the subcatchment to get a report window and look at the Summary tab. Here we can see all of the sub-area data that has been extracted from this plan. So in AutoCAD, we've done the cut-throughs of all of the layers, and we've identified each of these unique groups. Now you'll notice some of these are actually the same. There's a paved parking, soil group C, and then there's a second one that's the same as that. This is because there may be multiple pieces that are not contiguous within the subcatchment. So each of those actually generates a separate sub-area within the report. There's an importing option that we can enable to automatically consolidate those, to combine the matching areas and actually sort these alphabetically. At the moment, they're just displayed in the area that they're coming off the drawing. So we can consolidate those. But this listing can be handy because it shows you the total number of puzzle pieces, if you like, that are involved in this particular subcatchment 10S. If we select the second subcatchment here and open up that window, again, we have a list of the individual unique sub-areas within the subcatchment. If we try to edit either of these subcatchments, we get a couple of messages here, first indicating that manual node positioning is not allowed with the automatic import. This is because we've specified that we want to automatically position these nodes on the drawings. So this message comes up in order to prevent us from accidentally moving things around. If you want to move it manually, then you can uncheck the box, and now you could manually reposition that node. So this node can now be moved around, this one can't. So this would let you do manual positioning without disabling the whole import process. So the next time data is imported, it would still bring in the sub-area information, but it would not reposition this particular node. So essentially, we can do a selective override for individual nodes for particular kinds of information, deciding whether it's to be imported or set manually. Now, one of the interesting things we can do here is to make changes to the drawing. So for example, if we come to the subcatchment, let's open up the report window, and you can see that we have an area here of 37,000 square feet approximately. If we come over to the drawing, actually before I do that, there are result layers that have been created here containing the final unique sub-areas generated by this intersection process. We can turn off those result layers here on the menu, and there's also a shortcut key, a Control-R. And when I do that, some of the layers will be hidden on the drawing. So now in the drawing we are looking just at the raw input data, which is where you'd want to make any changes. So if I come to the drawing now and hover over a given entity, we can see that this polyline is drawn on the subcatchments layer. So this is the layer where all our subcatchment boundaries are drawn. We could make a change to this layer. Let's just select the polyline, and now we could drag any of these outline points and change as desired. And then we could come back into our HydroCAD model and do an import now, and it will repeat the entire import process. But we've now changed the area. We've now got 45,000 square feet in subcatchment 10S over on this side of the project. So the whole import can be updated anytime you need to, anytime there are changes made to the drawing. Now, other things worth pointing out here in this import process, there's this set of result layers that I mentioned where all the results are being compiled. That list you can access by going to the Configure Watershed button over on the right-hand toolbar. You'll also find this under Settings Watershed. Those will bring you to the same place. On the Watershed Setup screen, we have a list of all of the ground covers that are available within a particular lookup table. And then we have checked in this project the specific ground covers that are going to be used in this particular model. And then we are creating layers within our drawing that correspond to each of those individual ground covers. By checking just the layers we want to use, or the ground covers we want to use, it avoids creating dozens or 100 layers that would not be used within this particular project. So one of the things you're going to do as you set up these projects is to come in and customize the list. It's to pick the layers that you actually want to use. Down at the very bottom of this list, we have a group of special layers which are always checked. And these are the layers on which we are providing the subcatchment boundaries and the subcatchment numbers. Those are normally on different layers, although they could be combined and placed on the same layer. We also have a set of layers that are used for the soil group boundaries and the letters for the individual soil groups. And then we also have layers that can be used for land use analysis. This is an option, but if you've enabled the land use reporting and pollutant loading options, then we can actually draw the land usage boundaries and label those on these two layers. The final layers here are the result layers, and these are indicated with HCR, HydroCAD result layers. And the first of these is the sub-areas. So this is the primary layer that contains each of the sub-areas, the smallest unique pieces of ground that we've divided the project up into. Then there's also layers that are used for labeling the sub-areas, if we have that option on, and there's a layer that's used for hatching the individual sub-areas. Those are just to enhance your reports. They don't actually play a direct role in the calculation process, but they're available to you to improve the visualization of your drawing. And that's what we're seeing on the drawing over here. We can see the hatching that has been generated on that hatch layer for each of these ground covers. Continuing on the watershed setup screen, the second tab is where we specify the general import settings. And this includes the name of the drawing that's going to be imported into this particular HydroCAD model. We can also specify how the nodes are going to be positioned, what kind of units will be used, feet or meters, for the drawing. And then we have a whole bunch of input options. We can verify the line work that's being used to delineate our subcatchments, and we can even correct any errors that may be found, such as open polylines can be closed automatically. And then there are a number of options for result layers as to exactly what will be displayed on the final drawing. And we can also set default ground covers and default soil group. And finally, we have an option to consolidate similar ground covers, as I mentioned a moment ago. If we were to select this box, then all of the similar ground covers would be combined into one line rather than multiple lines on the subcatchment summary. We're going to come back to this screen in a minute when we set up a brand new project, but this is just to give you a general overview of the settings that are available and where they're located. As you're doing the import from AutoCAD, it's always worth reviewing your project report window. You're going to find that's quite handy because the tab here for ground covers will show you a summary of all of the ground cover information that's been imported for that particular project. So here we can see the areas and soil groups and the individual subcatchments in which each of those ground covers occurs. So I would urge you to make use of that. So that is a run through the sample project that's pre-installed with HydroCAD. Now let's go through and set up a project from scratch just to show you how you would set up all of these pieces on a project of your own. So the first thing we want to do is do a project open, and we want to create a brand new project. And let's just call that Webinar 3 at the moment. And yes, we do want to create that. So we have a blank screen. And before we go in and configure the watershed, there are two things that you'll find handy to do ahead of time. The first is to go to the Units screen, and you can get there, of course, with Settings Units or the corresponding button on the right-hand toolbar. And at the top of that screen, the box is usually checked to use large units for areas and volumes. What this means is that the project is going to report areas in acres as opposed to square feet if we were working in English, or if we had switched to metric, then it would be reporting in hectares as opposed to square meters. It's often easier to uncheck that when you're doing an AutoCAD import, just so that your numerical values in HydroCAD are square feet, and they're easy to reconcile with what's happening in your drawing. Of course, you can change this at any time. This is just a reporting preference. It doesn't change the underlying data. So I'm going to uncheck that. Then the second thing I want to do is to set up some rainfall definitions or event definitions for this project, just so we can open up the report windows without getting an error that we have no rainfall data. And I'm going to import rainfall events from a lookup table, and we can just come down to this table. I'm just going to pick a random state and county here. And so now we have a list of rainfall events that have been defined. If we click OK, you can see that our rainfall event selector is now populated. So we've now got basic information that we need to work with this project. So the next thing we want to do is we need to configure the drawing and the import settings that are going to be used. So we're going to come over to the Watershed Settings button, and let's skip over to the Import tab first, and we want to configure the options here. First, we need to select CAD Watershed Layers as the import option. And this is what specifies that we're going to go out to AutoCAD and grab that data and bring it into our HydroCAD model. There are quite a number of import options that are available on the screen. The most important is to pick the file that you're actually going to import from. And I have an empty file already set up for this project. I'm just going to grab that just to save us a little bit of time. And then we go through the various import options. Generally, is useful for the nodes to be positioned automatically. We can set this to position them to the center of each subcatchment area, or we can position the node according to the label. So that gives us a means of more precisely positioning the nodes on the diagram. Drawing units, we can generally leave it automatic. What automatic means is that the drawing uses the same length scale as we are using in the HydroCAD file. So if we set it to automatic, if your drawing is in feet, then your HydroCAD file is assumed to be in English units in feet. If the drawing and project are different, that is, if your project file is set to metric but your drawing is in feet, then we could specifically say the drawing's in feet. Or if the project's in feet and the drawing's in meters, then we can specify that. So this allows us to manage mismatched drawings, if you like, and automatically convert the data. But if the units are the same as they typically are, then the automatic setting will work just fine for you. The next import options, which we generally want to use, is to check the polylines. This just verifies that the polylines are not self-intersecting and that they are closed. And we can also fix certain polyline irregularities if we check this box. So it will attempt to automatically repair some of those errors in the polylines. And then we have options for result layers. We can turn on the hatching to aid in visualization. We can label our ground covers so that each of those are shown with text on the drawing. And then the result layers typically are locked, and this is just to prevent inadvertently editing the result layers. If you wanted to make a change to a subcatchment boundary and you accidentally change the result layer rather than the original layer, then that result layer gets erased every time you do the update. So locking the layers helps to guide you back to the correct layer for making those input changes. Finally, we can make sure those result layers are displayed. They can be generated and hidden, but this will show them. And then the hot track feature is very helpful. This is what automatically highlights an entity in the AutoCAD drawing whenever we've selected the corresponding node within HydroCAD. And finally, the auto view feature is associated with that. This will automatically pan and zoom the drawing as necessary so that those entities that are being hot tracked are fully visible. Over on the right-hand side of the screen, we have options for setting our defaults. Normally, there is no default ground cover or soil group, so if we wanted to map every square foot, we could just leave the defaults at none. But if we want to make use of the default capability, then we would want to come in here, and so we might set, let's see, we can come down to woods in good condition as a default ground cover, and we could set a default hydrologic soil group B for this particular project. And then we have options here for sorting the sub-areas alphabetically and also for combining the similar sub-areas as I've mentioned. I'm going to leave those off for the moment. We can come back to those later. So with this general import information set up, now we want to come back to the ground cover tab. On the ground cover tab, since we've enabled the CAD import capability, a column has now appeared here for the layers. These are the layers that correspond to each of the individual ground covers. And one of the things we want to do is to select just the particular layers that are going to be used within this project. And rather than having to uncheck all of the boxes we don't need, we can come down and click Select None, and that will uncheck everything. And we could now come through here and we could pick a grass layer, and perhaps we'll pick paved, let's see, parking up here, and we could pick gravel roads. So you would just select whichever layers you anticipate using. You can always come back in later and change the selection. You can add additional layers, or you can remove layers if you don't want them used any further in that particular project. Once we have the layers set up that are going to be used, or the ground covers set up, then we need to actually create those layers within the drawing. And so we can use the Verify Layers button for this process. Verify Layers goes out and opens the drawing file that we've specified. In this case, it's a new empty drawing. And it checks the actual layers that exist in the drawing. Again, looking at the drawing, you can see our layer list is empty here. All we have is layer 0, which exists in every drawing. So HydroCAD has done a layer verification, and it's telling us that there are 12 missing layers. That there's 12 layers we need in order to complete this analysis that do not exist. And by default, we have the option to automatically create those layers. So if we click OK, it will go through and create those layers in the drawing file. So it's created a layer for each ground cover, HC grass, paved parking, gravel roads, etc. And then it's created result layers for sub-areas and the text that's going to be placed on those and the hatching. If we have a look at our AutoCAD window, you can now see that those layers have now been defined. So all of the layers that are necessary for this core data now exist. Of course, there will normally be other layers in your drawing. You can have whatever layers you need to design your site. These are just the additional HydroCAD specific layers that are going to be used. Now, you're not forced to use these specific layer names. It's quite easy to reassign the layer names. For example, if we didn't want to use gravel roads here, or HC gravel roads as the layer name, we could just double-click that line to go to an override box. And on the override box, we can override any of the standard settings for that particular ground cover. And this includes picking a layer name. And we could pick a layer name that's specified within the project, or we could actually go straight out to the drawing. And those are the live layer names coming off the drawing. You can see layer 0 is appearing there as one of the options. So if I pick layer 0, for example, and click OK, you'll see now in the column for the layers, we have here in braces the layer name 0. So these braces indicate an override that's been specified, and we can override a lot of these different values. This makes it much easier to customize the settings that you want for an individual project rather than having to create an entire custom lookup file. If we want to remove those overrides at any time, we can just click Clear Overrides, and that will remove them and set everything back to the defaults. Now, the table we're looking at here is based on a default ground cover file which is automatically installed with HydroCAD. And that's shown on the lower left-hand corner of the screen here. This default file is CN020. The 020 indicates the initial abstraction ratio of 0.20. That's how the file name is assembled. The reason for that is because if we were to use a different initial abstraction ratio, then all of our curve numbers would need to be different. So this particular file, the standard file that's used with HydroCAD TR20 and TR55, is based on this ratio of 0.2. If we created a different custom ground cover file, then we could select the file from that drop-down list, and that would repopulate this entire table based on that file. In most cases, rather than doing a custom file, it's much better to override individual items as we've done here. There's also a capability to create an override file. This is a file containing just specific overrides that are to be applied to this project. So for example, if we were importing data from a Carlson hydrology drawing, which may use slightly different layer names, then we can select that override file, and you'll now see down the bottom we have in square braces here override layer names that have been provided for these different soil groups and subcatchment boundaries. So that's another purpose for which you can use the override file. Other features that are very powerful here is to set up layer sets, particularly when you're doing a pre- and post-analysis, or if you're simply analyzing multiple scenarios. They might not be pre and post, they might be several different design alternatives. If we drop down this list, there are a couple of preset options here. If we pick pre, for example, for pre-existing, you'll notice that the layer names will be automatically changed up here on the screen. And it's inserted a pre on all of these layer names for us. So now we can have 2 or more different sets of layers within the same drawing file with names automatically assigned. The only layers here that do not get automatically renamed are actually the soil groups, because typically your soil group assignments are the same in your existing and your proposed condition. If you do need different layers for soil groups, then you can simply set those with a manual override, and you can pick the layer that's to be used for each of those. But the automatic layer set capability normally keeps those the same. You could also pick one of the numbers for the layer set, and this would simply correspond to different scenarios. Scenario 1, 2, 3, 4, perhaps different design alternatives that you're looking at, and it automatically changes the layer names. Of course, once you've changed the layer set, you'd need to do a verify layers and have it create the missing layers so that your drawing would contain each of those sets. I'm not going to actually use the layer set capability in this particular example, so I'm going to leave that at none, but just to let you know that that little box is hidden down there, and it makes this process of modeling pre and post or different scenarios much easier than if you had to manually manage all of those layer names. Okay, that is a fairly complete run-through of all of the settings that are available to you here on the Watershed Setup screen. Again, we start with Watershed import settings by specifying the CAD import, picking the drawing, and then we go through and we define the specific layers that we're going to need. In this project, verify the layers. When that's done, we can click OK to save those Watershed settings. And we now have our blank HydroCAD project, and we've got a blank drawing in AutoCAD. Now, you're probably going to be starting with an existing drawing of some kind, but just to show you all of the elements here, I'm starting with a drawing that's completely empty. So the first thing we want to do on this drawing, let's start by drawing a subcatchment outline. That's really the most fundamental piece of information that we need in order to get this process going. So if we come down to the HC subcatchments layer and activate that layer, we can now come over into our drawing, and what we want to do is draw a polyline as complicated as you need it to be, and I'm going to close that manually, although we could leave it open and use the automatic repair option in order to automatically close that when the import occurs. So we've drawn a subcatchment. The next thing we need in order to make that functional is we need a subcatchment number. So we need to activate the subcatchment number layer, and then we need to put text on that layer. And what we want to do here, no, I actually want, you can use either single or multi-line text. My cursor keeps moving on me here. That's the trouble I'm having. Okay, so if we put in a subcatchment number such as number 10, and the size doesn't matter, the color doesn't matter, you can set those as you choose, as long as it's located within that particular boundary, then we'll be all set. And I'm obviously having trouble here. The air conditioning is actually blowing my mouse around on the table, which is messing this up. Yeah. Okay. So you can go ahead and label your subcatchment basically anywhere you choose. So that's the essential core information. Now we haven't yet drawn any ground covers or any other information. So if we do an import on this, and let's go ahead and do import now and just see what happens. Now it's actually paused waiting for AutoCAD because we still have the import mode over here for single line text. And so we get a timeout that says AutoCAD's busy. So for some reason I lost the text that I'd put in over here on the drawing. So let's come back and do this one more time. And let's put in our text here. And I'm just not having any luck with this here today. Okay, so we've got some text on the drawing. And we might have another subcatchment over next to it. So if we were to come over to our subcatchment layer, and it's just losing my text here every single time. I think what I'm going to do here is I'm going to jump over and grab another drawing that I've got just so we can keep moving along. So let's go back to our Watershed settings screen. And I'm going to grab a practice drawing that I have here that I set up earlier. And let's do an import off this drawing, and we'll work backwards off this. And we have some layers that don't exist on this particular drawing. So let's go in and verify our layers and do an OK. And then do an import now. Okay, so we finally have some data that's been imported here. So let me work backwards and take some of this drawing apart just to show you what's going on here. Let's go through the layers, and what's often easiest to do is to start by turning off our result layers. So we'll get rid of that just to simplify things a little bit. And then we'll come back into the drawing and basically turn these off. So we have layers here for the different ground covers. Let's remove those. And the soil groups. And so what's left here is we've got our subcatchments. So we have our subcatchment numbers that are on one layer, and we have our two subcatchment layers. And what we need to do is to turn layer 0 on here so that I can now turn the numbering and the outlines on and off. Okay, so these are the two subcatchments that we've set up. And you would normally need those subcatchment boundaries to coincide. You want them to precisely share the same points along the boundary. If there's a discrepancy in the boundary, then that will typically be detected by HydroCAD, and you'll get a warning message, such as an overlap that may occur between the boundaries. The subcatchment labels need to be on the appropriate layer and located somewhere within the outline. Then the next layers that we've defined here would be our individual soil groups. So in this instance, we have a certain amount of grass that's been defined, overlapping those two layers. And then we have a very rough gravel driveway, and we may have an area of parking. Now, this process has the ability to handle islands. So in this instance, this parking is an island within the grass area, and when it does the layer analysis, it will actually cut that out of the surrounding grass. So we'll have a grass outline with a hole in it. And this is one of the reasons that we're using regions when we do this final processing in the extraction, because the regions can handle these complex shapes, including donut holes within the middle. We also have layers here that are used for the soil groups. So here are our soil group outlines. And in this instance, we just have a single soil group that's been mapped. And then within that, we do have to specify the soil group letters. So you see the soil group letter C. Again, we need to make sure that's on the right layer or it won't operate properly. And we can also do land use mapping, which has been specified in this instance. This is strictly optional, but if you want to do land use analysis within your project, then we can turn on those layers as well. And so here we actually do have some land use analysis that's been done. Let me just delete that for the moment. And that was the label that was applied to the land use analysis, so we can remove these other pieces. And so, of course, you can come through and just make whatever changes you need to on these different layers. So if we do an import now, I've removed one of the subcatchment outlines, so we're now just going to get a single subcatchment. And the data has come in for that one subcatchment. We still have some default areas that are being used for both the ground cover and for the soil group, because we have not explicitly mapped all of those areas within the model. That's completely up to you as whether you want to map all of them explicitly or use the defaults. If we want to now add an additional subcatchment to the model, let's do a Control R here to turn off the result layers just to make it a little easier to work with the drawing. And we can come over to the subcatchment layer and activate that. And so now coming into the drawing, let's draw a polyline. And let's start up here with this corner. And we could come back here. And normally we would want to use those same points and then close it. So now we have two polylines which share the same three boundary points. And we already have our subcatchment number positioned in the middle there. If we do an import now, we're going to see two separate subcatchments that come into the model. So if we now click or select either one of those subcatchments, you'll see the corresponding sub-areas get selected in the drawing file. If I switch over and select subcatchment 20, the same process happens there. And in fact, this hot track capability also works between multiple projects. We still have our original CAD import demo open here. If we switch over to that, it toggles the HydroCAD or the AutoCAD view over to that drawing, and we can now select subcatchments within that project. So the hot track goes back and forth between the two, keeping all of the highlighting synchronized as you work between them. There's another handy capability here. Let's just make sure our result layers are turned on, which they are. If we come in and edit this particular subcatchment, normally it's protecting us from making editing changes. Let's go to the Area tab, and again you can see we're blocked from editing. But we can uncheck the box here, and that will allow us to manually make changes to the sub-areas. Now in this instance I'm not going to make changes. What I really want to do is show you another feature of the highlighting capability. If we select a specific line on this table, that area gets highlighted within the drawing. There's a subtle flashing that's occurring of the area. And actually, if we right-click a sub-area and select Find, it will center and flash that within the drawing. So this is a very handy capability. If you find you've got very small areas showing up in this list, or areas you don't recognize, something that you have a doubt about, then you can use this capability of just a normal click or a right click and a Find area, and it will find that. Because you'll find that as your drawing gets complex, you can get some very, very small little puzzle pieces that are being left as a result of this intersection process. So that will let you identify them. Let's just cancel this, and we'll leave the edit protection on for that particular subcatchment. So you can basically go ahead and make any changes you need to the drawing and do the importing. If you want to use land use reporting for this particular file, then we would go to the land use settings screen and enable the land use reporting box. And this will automatically assign land uses to each of the existing ground covers within the project. At the moment I'm not going to turn on pollutant loading. We can do that separately. It doesn't directly affect the import process. I'm just going to turn on the land use reporting. And so now when we do the land use reporting, it's also going to pull in data from our land use layers. And over in this sample project, I believe we already had a couple of land use layers that had been defined. Yep, there's our land use text, and also the custom ground cover or custom land use text that had been assigned to that layer. And that, again, that just has to be located within the outline, much as you would on the subcatchment layer. And that will cause it to bring in an explicit ground cover or land use mapping into the subcatchment. So if I do the import, the subcatchment report is normally going to show the default land use that is pre-assigned to a particular ground cover. But if we map that particular land use and then label it, then it will override that default setting and allow us to explicitly map the land usage for each area within the project. A lot of different options here, as you can see, and it's likely that you won't use all of these on most of your projects, but all of these things are available to you. So that is a general overview of the import capability. As I've mentioned, you have the ability to set layer sets in order to handle pre and post. And once you've defined a project with the specific layer settings that you want, the import settings, there's also the capability to load those settings from one project file into another. So this makes it much easier. You don't have to set up everything from scratch when you define a separate project. So I would urge you to have a look at the CAD import demo project, which is pre-installed with HydroCAD. That'll give you a good idea of how the basic capabilities work. And then just start small, start with a simple project and build your layers. When you work with an existing project, you're going to find there's a lot of information coming in, and it can take a little bit of time to reconcile what's happening in the HydroCAD side of things with all of the small cookie cutter pieces that are coming in. But this hot track ability, which will show you the sub-areas that are associated with a particular subcatchment makes it much easier to troubleshoot these problems. One of the things that you may have occur to you, let's turn off our result layers here again. And if we come back to the drawing, let's take this particular subcatchment and let's edit that subcatchment boundary. So we're now overlapping these two subcatchment boundaries. This is something that you generally shouldn't do, but I want to show you how it behaves when we do the import. And if we do import now, at the very end of this process, HydroCAD is doing a cross-check on the subcatchment boundaries. So if we come down to the message window, there's a couple of interesting things that have happened here. First of all, we have two lines that have been skipped. And these are the lines out of the table that's coming into HydroCAD. And they've been skipped because there's too many node number values. So we have two areas here that are coming in, and each of those areas includes a number 20 and a number 10. These are the values that it's complaining about. And what's actually happening is it's this overlap area in the middle. This overlap actually indicates that this first subcatchment includes the number 10 and also the number 20. So the overlap area is basically double numbered is what's happening. That's why it's complaining about those two lines. So two lines of input data have been skipped because of those particular problems. Then after the sub-areas are imported, HydroCAD is reconciling the total areas between the subcatchments. And it's finding a mismatch here. It's finding that the sub-areas imported within each of these subcatchments is different than the area that's enclosed within the overall outline. And again, that's because of the overlap that shows up here. One of the interesting things you can do here is we can come down to the message window, and if we click one of these lines, it will actually highlight that particular area on the drawing. So as I select each of those, it's bringing up the help window in the middle. Let me just move that over. But you also notice that the highlighted outline is changing as we toggle between them. So we can use this in order to identify the specific places that it's complaining about a problem within the drawing. We can also do a right-click on any one of those and do a find node, which will center and flash that particular area on the drawing, as well as selecting the node within the HydroCAD project. And that can be very handy if you've got a very tiny sliver of overlap, which can sometimes occur when you're drawing two matching boundaries. This will make it much easier to find those slivers and correct them. Okay, well, that's a pretty complete look at the different AutoCAD import capabilities. You'll find a lot more information on all of this, of course, in the help system within HydroCAD, as well as the CAD import page that we have on our website, which has got complete details. And, of course, do have a look at this CAD import demo project, which is pre-installed with HydroCAD. If you've got any questions, certainly feel free to contact us at support@hydrocad.net is often the best means to reach us, and we'll be glad to answer any specific questions you may have. Thank you very much for joining us for this session on AutoCAD import. Again, we'll have this recording posted later today, so you'll have the opportunity to view that. And I hope we'll see you again at a future session. Thank you, and have a great day.